Welcome to this tutorial on integrating Virgil Security into an existing chat application. In this demo, we're going to use a chat application that I've written in Rails using ActionCable and some front-end JavaScript. As you can see, Bob and Alice want to have a conversation, but currently all their messages are stored in plain text on the server. So Bob thinks, can we add Virgil Security to this picture? Now, Virgil Security has two sides, a client side and a server side. So we're going to tackle the client side first. So we're going to start by adding the JavaScript SDK into our main HTML page. This SDK will add a Virgil global variable that we can then use to create keys. Now, to create keys, we're first going to have an account. So head over to virgilsecurity.com and sign up. I already have an account, so I just sign in, and let me show you how to create an app as well. To add an app, just give it a name, you can give it a description, give a password for the key file, and then make sure to save that key file to disk. We'll need this file later. This is the private key for your application, and you really need to make sure you save it because Virgil does not save it for you. Next, we create a token. And really all it needs is the permission to create and search for private keys. We give it a quick name and we save the key. Yep, there we go. Great. Now I'll copy the key, head over to my JavaScript file, and I can save the, I can use the key here to initialize our client-side SDK. So in this case, I'm going to call it API. I'm going to say virgil.api and pass in that access token that I've just created. Let me copy that again. I think I might have missed it. There we go. Okay, next up we'll need the sending and receiving usernames of the two people involved in the chat. I've made this really easy because I've added some stuff in the HTML, two data attributes, data.me and data-them. And we can use these to really, with some simple JavaScript, some jQuery, we can extract these, and we will use this further on in the app to know who to encrypt and decrypt messages for. Next, I need my own key. I need my own key because that is the key that will be used, that I will use to sign or decrypt messages sent to me. Now, initially, I won't have it yet, so we'll set it to null. In the next step, once our server is connected to the client, once we have that connection, that chat connection, we're going to want to find the key that is stored in the browser. Each client, in this case the browser, will need its own key. And in this case, what that means is that we're going to have to try and find that key. So we'll try and load that key, and we'll use the username as an identifier, my username as an identifier. Now, if that does exist, we'll initialize my key using that key. If it doesn't exist, we're going to have to create a key and a card. And I'll come to what a card is in a moment. And finally, this last thing will always happen is we'll initialize the UI once we've either loaded or created our first key. Now, the next step is to implement those three functions. So the first one is to just init a key. This is when we've loaded the key from our local storage, and all we really have to do there is just set my key to key. If our key doesn't exist yet, we're going to have to create a key and a card. So we'll create the function create key and card. It doesn't take any parameters. And what we're going to have to do here is a couple of things. First off, we're going to create a new key, and we're going to set it to my key. So api.keys.generate. This will create a new key pair for us that we can use to encrypt and sign. We'll then save that to any identifier really, but in this case we're just going to use a username. And then finally we're going to have to create a card. Now a card is basically your public key signed with some extra information. And we'll send that to the server for the server to then publish that to Virgil. So we'll create a card, api.cards.create, and we'll pass in an identifier again. We'll use my username again here for convenience, and my key. Next, we need to publish this to the server because the server needs to publish this to Virgil so that any client can look up these cards by the given identifier, in this case the username. We'll come around to creating that method in a moment. Next, we'll want to write the method that is always called, which is to initialize the UI. What I'm going to do here, very simple, is I'm going to by default hide the text area for inputting new messages. And when we've loaded or created a key, then what we'll do is we'll just show that text area again. We'll come around to hiding that text area in a moment. So from these three things, the only thing we're kind of missing is how to publish a card. Now, publishing a card means that it needs to be sent to the server, to our application servers, our Rails app. So app.chat is just our ActionCable kind of connection to the server, so we can just add a new method to that called publish card. It takes the card, and really just all we're going to do, and again, this is some Rails specific code that has nothing to do with Virgil. We're just going to call publish card on the server side, and we're going to pass in the card. Now the problem is the card at that moment is a buffer, which isn't really very nice to send, so we'll export it to a string, which will make it a lot easier to kind of serialize to JSON. So what's next? Yeah, the one remaining thing is to hide the text area when we load the UI. That way the text area won't show until we're completely ready to start sending and receiving messages. Finally, the next step is on our server side, we're going to want to publish the card. Now, publishing a card requires that we also have the SDK installed on the clients, on the server side. So the first thing we do is we add the Ruby gem, the Virgil SDK gem. We make sure to bundle, and you probably want to restart your server as well at this point. We then go to our file and we require the Virgil SDK wherever we need it. And there's different ways to use the SDK, but I always like using the high-level SDK, which makes a lot of these things a lot easier. If you really want to deep dive, you can use the lower-level SDK, but including that one makes it a lot easier. And then we're going to have to initialize our Virgil API. Now, on the server side, that's a lot more complicated. We'll take an access token again, but we'll also take the app ID, the Virgil key, which for convenience I've just copied into our app. And we'll load that key, we'll load it from file, and we'll pass in the key password as well that we created when we created the app. And that way we've set up our key for the server side. Now we're ready to implement the publish card method on the server side. So the publish card takes that card data in, and what we will do here on the server side is we'll just import that data. Oh, actually it needs to be data. So we'll import that card because we exported it before. And then all we really have to do is we just have to tell Virgil to publish the card. Now what this will do is this will sign the card as well with your private app.virgil key before it gets sent to Virgil, so that Virgil knows for sure that you indeed signed that key before you send it over. Now in this case we're ready to kind of reload this, and as you can see right now the text area shows up, which is great, and we'll have some Virgil keys created. Now of course if I now send a message, nothing has actually changed. It's still just, it's still unencrypted messaging, which is a bit disappointing. So we're almost there really. At this point we're ready to start to send and receive encrypted messages. So the next step really is to encrypt the messages before we send them. The way we do that is we have to find all the cards for all the participating parties, which in this case we pass in the username of both myself and the receiver. And the reason why we pass in both is because it makes it a lot easier for us to decrypt the messages that we send ourselves. Otherwise we'll have to store them and cross-reference them against each other. That method returns a set of cards, and then we'll move this on the inside. And now we want to turn that message into an encrypted message. So we'll call that encryption message cipher. Now we'll take our key and we call the method sign then encrypt. And what that does is it will both encrypt and sign the message at the same time. It will use my key to sign the message, to make it very clear to any recipient that I was the sender. And it will use all the cards to encrypt the message so that only they, with their keys, can decrypt it. Again, that's a buffer, so let's turn this into like a base64 string. And then all we have to do is just send that cipher instead of the message. Now if we reload our message app, we can write a message like this is encrypted, and what you will see is that got turned into an encrypted string. Great, that worked. Now the problem is we now need to decrypt that. So how do we go about that? Now the simplest thing for us to do is we're just, if we look at the content on the server side, it is encrypted, but we're just going to delete them all because we now had a mix of encrypted and decrypted messages. So let's just clear it all out so that we only have those. And what we're going to do is we're going to mark each message in the UI by default to just be encrypted. That way we can know which ones we've decrypted and which ones we haven't. And by default, we're just going to hide all the encrypted messages until we've decrypted them. So we do that like that, just a little bit of CSS. So as you can see right now, if I write a message like test, the message will arrive, but it's not being shown because we haven't decrypted it yet. So the final things to do is to write a decryption method. So that function, let's just call it decrypt messages. It won't take anything. What it will do is it will use some jQuery to find all the messages that are still marked as encrypted. And then for each one, we're going to decrypt them. So we're going to pass the element. There we go. So let's copy paste some stuff in here. So we'll extract the message. This is the message object. We'll extract the cipher, the encrypted text from that. And we'll extract the sender from that as well, because I've passed in another data attribute with the sender attached to each message. That way we know who actually sent the message. And then we're going to do the reverse of what we did with encrypting. We're still going to find all the cards, but we're just going to find them just for that sender. Not for the receiver either, not for me, just for the person who sent me a message, which actually might have been me. That will return a set of cards, plural, because a sender might have multiple devices, multiple clients that they're logged into. And to turn that cipher back into a plain text message, all we have to do is say mykey.decrypt then verify. So it's the complete opposite. Before we did verify then sign then encrypt. Now we do decrypt then verify. We pass in the cipher and the cards, and because that will return a buffer, we will turn that into a string. Like we said, in this case we use my key to decrypt, and because my key only lives on this device, I'm the only one who will be able to decrypt. And we'll use the cards that we looked up to verify that one of those cards at least is a card that created the signature for this message. We'll finally set that plain text on our message and mark the message as decrypted. We're almost there. Final two things. First off, every time we receive a message, we want to make sure that we decrypt all messages. And then probably each time we load our application, so when we init the UI, we want to decrypt all the older messages as well. So with that in place, we now can see that test is being decrypted on both sides. Bob can send a message to Alice, which will automatically be decrypted by Alice. And it works the other way around as well. If you look at our database, you'll see everything is still encrypted. The last message, the content of that is indeed encrypted, and it's only being decrypted on the client side. That's it for this screencast. Thank you very much for watching.